Hello, welcome to Biofree lecture. Um, we will start module 6. We will talk about metabolism, energy, and enzymes. So we will talk about energy first. We'll cover the two laws of thermodynamics and two types of energy like kinetic energy and potential energy. So as you know that we are living organism. All living organisms require energy. Where do we get energy from? Well, before that, we need to define energy. Energy is the ability to do work or bring about change. This is a good definition. Well, all living things require a constant supply of energy. That explains why we have to eat at least 3 meals a day. The food that we eat provide us with energy so that we can, carry on the process of life. In here, we only give you 5. Do you remember the 7 characteristics of a living organism? These are the 5, and then we have 6. 6 is a response to stimuli. And number 7 is organization. Well, at the beginning of the semester, we group growth and development into one point. So what is the you may call it the second point. If growth and development are one point, then what will be the second point? What will be the second point? The second point will be adaptation. So this is like a review for your earlier lecture. Basically, we need energy to maintain all these 7 characteristics of a living organism. Another reason we need energy, constant supply of energy every day, because we need energy to maintain our body temperature at around 37 degrees Celsius. If you look at a lizard or a snake, what they do all the time, they basically lie on a rock in the daytime. Why? Because in the daytime there's a sunlight will heat up the rock, so that when they are lying on the rock, their body can absorb the heat from the rock and also from the sunlight. And they are not isotherm like us. We are isotherm, so we can keep our body temperature at 7 degrees. And that's why we need to eat all the time. And So, what is the ultimate energy source on Earth? Do you know? I already briefly mentioned that from the last slide. Yes, our ultimate energy source on Earth is the sun. Well, I don't know if you have watched the movie Matrix. What happened in the future is that, okay, somehow the Earth is over polluted, so the air pollution is too much, and then the sunlight is blocked from going to the Earth, so all the plants die. When all the plants die, then we don't have food. We don't have food. We don't have energy. When we don't have food and then we don't have energy, then what happened? The computers start collecting or harvesting human being to produce energy. So that's why the sun is very important. It's the ultimate source of energy on the earth, for everything on the earth. Okay, so most of the organism, we get the energy from the organic material produced by the photosynthesis. The organic material, they are usually glucose or sugar, because that's the food for almost all living organism. Glucose. We use glucose to make ATP. And what living organism can do photosynthesis? Well, algae, plants, and some bacteria. Only some, not all bacteria can do that. If you remember our previous lecture, we talked about a bacteria called cyanobacteria. Cyanobacteria. Cyanobacteria is a type of bacteria that has chloroplast, and they can do photosynthesis. And we call the living organism that can do photosynthesis or that can produce food by themselves, we call them producer. Well, the producers that we're talking about is different from the producers for TV or movie, okay? The producers that we're talking about in this class are the living organisms that can do photosynthesis, meaning that they can make food, make glucose by themselves. And well, of course, life on Earth is dependent on solar energy. But what about human being? You may argue that, well, we're farmers. Farmers can also produce food. Okay, farmers, they grow food, and the food that they grow, they are producers. Okay, what about cattle or human being? We are called consumers. We consume food. We consume producers, and we consume other consumers like beef or chicken. So producers are the one that can make their own food. They are the one that can do photosynthesis. That's why we call them producer. We are all consumers, including farmers. So energy, well, the definition of energy is the ability to do work or bring about changes. We already talked about this definition. There are two forms of energy that we want to cover. One is called kinetic energy. Basically, energy used for work. Well, work is a little bit generalized. Maybe you can call it energy used for movement. Okay, Potential energy is a stored energy. Yeah, you can call it this way, stored energy. Cells and the flow of energy. So kinetic energy is the energy of motion. Okay, this is much better. It's the energy of motion. For example, one example of kinetic energy is mechanical energy. So energy of motion. So you can see that okay, the leopard is running. So the leopard is using ATP as an energy to move. Okay, the car is also moving. Well, we all know that car require gasoline to burn so that the engine can move. So gasoline is a form of chemical energy, and then the car convert the chemical energy stored in the gasoline to become kinetic energy so that the car can move. Similarly, the space shuttle and the satellite, they can move in the space because they also burn the fuel, which is a form of chemical energy, and then transform the chemical energy into a kinetic energy for them to move. Okay, this thingy, we played that when we were kids. It is also a form of kinetic energy. Okay, another forms of energy we want to talk about is called potential energy. It is the stored energy. An example I already briefly mentioned in previous slides, it is the chemical energy. Chemical energy is a form of potential energy. For example, it's not shown in here. Potential energy is the energy stored to do work. If we blow up a balloon in here and then we let go of the air, then the balloon will fly away because the potential energy stored in the balloon will propel the balloon to fly away, so it becomes a kinetic energy. Also the spring, if we compress the spring or if we stretch the spring, then the spring will go back to its static state. When the spring goes back to the static state, then you will have a form of a movement. Then it is also a potential. It is an elastic potential energy. And then the potential energy can be in the form of height. So if we ride a bicycle so that we move the bicycle to the mountain top, then the bicycle store a lot of potential energy, and then when we go downhill, then we basically don't need to pedal. We don't need to pedal, and the bicycle can just roll downhill by itself because we are using the stored potential energy to move downhill.